Hi everyone, so in today's lesson we're going to be talking about energy efficiency. Now, energy efficiency is related to energy because it's looking at the transformation of energy into one form from another. Now, when you were reading in your textbooks, you were talking about the different types of energy. Now, some of the key types that we've already talked about, and one of them is electrical energy. And electrical energy is basically the energy that you have in moving electrons. Now, another form of energy that we have is radiant, which is basically the energy that you have from electromagnetic waves. And when we're talking about electromagnetic waves, we're talking about light, we're talking about UV rays, we're talking about microwaves, etc. and etc. Now, you just finished reading about this in your textbook and writing it on your workbook pages, so I'm not going to go into a lot of detail. But what we are going to be talking about is energy efficiency. And energy efficiency is basically just a simple calculation to see how efficient an electrical device is in using the energy available and transforming it into usable energy. So energy efficiency gives the percentage of energy consumed. So the key thing is we're looking at how much is consumed by the machine or system that was transformed into useful energy. Now, when we're talking about useful energy, we mean energy that can be used to do a function. So, for instance, if we're talking about a light bulb, the useful energy would be the energy that the light bulb transforms into light. If we're talking about a motor, the useful energy would be the energy that the motor transforms into movement. Now, the formula for useful energy efficiency is actually quite straightforward. It's our useful energy divided by our total energy. So total energy meaning energy that you have available going into the system times 100, because the key thing is that energy efficiency is given as a percentage. So what we're going to do is we're actually going to do some practice questions about how to calculate energy efficiency. Now, before you ask, yes, you do need to copy this down, so pause the video while you copy the question. Okay, so if we're looking at the question, we have a light bulb on for 15 hours. So just like we did in class all the time, we underline our key information. Consumes 1,170,000 joules of energy. During that time, it emits 99,415 joules of radiant energy. What is its energy efficiency? So if we're looking right here, this value is going to be our total energy, and this value right here emits 99,450 joules of radiant energy. Well, that is going to be our useful energy. So if I'm looking at my equation, energy efficiency is equal to useful over total times 100. So that means we get energy efficiency as equal to 99,450 joules divided by 1,170,000 joules times 100. So when you do this calculation, you get 0.085 times 100. So that gives us a final answer of 8.5%. And you might think, oh wow, this is actually really low. No, that's actually quite common for light bulbs because most of the energy, right, when we're looking at energy efficiency, does not get changed into useful energy. Sometimes you have energy that gets changed into wasted energy. And in this case, a light bulb, most of the time the energy wasted would be heat. Okay, so that's for our first practice question. Let's start our second practice question. Okay, so just like last time, I'm going to pause so you can write down the question. Now we have the following. A kettle has an energy efficiency of 24%. Okay, so right now they're actually asking us to work backwards, so EE is 24%. If it consumes 8 kilowatts of energy, how much energy was converted into useful energy? So they're telling us we're looking for useful energy, so that means this is our total energy. Now, if you'll notice, in the last question we had energy given to us in joules. In this question we have energy given to us in kilowatt hours. When we're doing energy efficiency, it doesn't matter whether they give you in joules or in kilowatt hours, as long as the unit are consistent. That means that useful energy and total energy are given in the same unit. Okay, so we write down our equation. Energy efficiency is equal to useful over total times 100. So what we have, so we're going to just plug in. So we have 24% equals X, because we don't know what our useful is, over 8 kilowatt hours times 100. Now the first thing that I'm actually going to want to do is get rid of this times 100. So again, when we bring a multiplication to the other side, it turns into a division. So we would get 0.24 is equal to X over 8 kilowatt hour. And again, when you're trying to get rid of a division, we multiply both sides by 8, and we would get our final answer of 1.92 kilowatt hours equals X, which again is our useful energy. Okay, so the remaining practice calculations are on the class website. So what I'd like you to do is to go through them, and then after you've gone through them, the answer key for them will be provided so you can check how you're doing your work. Okay, thanks for listening. Sorry I'm not there today, but I will definitely be there for your quiz. All right, bye.